This is an important lecture on the naming or nomenclature of refrigerants. We also be using the term designation of refrigerants. So nomenclature, naming or designation of refrigerants is the topic of today's discussion. What I mean by designation, that would be discussed later, but let me start with why do we require to name refrigerants as R11, R12, R22, R404 like this. The reason is convenience, and the reason is uniformity across the world. So ASHRAE, American Society for Heating, Refrigeration and Air Conditioning Engineers, have come up with a common nomenclature which has to be followed everywhere where the refrigerants are used. The chemical formulas of refrigerants are a bit tedious, and referring to the chemical formulas always, like dichloro, difluoromethane and whatnot, that becomes inconvenient, especially when we are dealing with the customers, the commercial customers. So it is a good idea to formulate a naming system, nomenclature, which is convenient and which also gives us an idea about the chemical formula. So what is this system which has been agreed upon that we will be discussing? Refrigerants, as we had seen earlier, they are classified as broadly into the natural substances and the synthetic substances. They can also be classified as organic refrigerants and inorganic refrigerants, as well as synthetic mixtures. The famous organic refrigerants we have seen, that is chlorofluorocarbons, CFCs, they are the hydrocarbon derivatives in which hydrogen is replaced by chlorine and fluorine. We have also discussed HCFCs, hydrochlorofluorocarbons. Then we have discussed HFCs, and we also discussed hydrocarbons as the refrigerants. So there is a particular way of naming this refrigerants which has been agreed upon that we will be shortly seeing. We will also be discussing the inorganic refrigerants like ammonia, how they are named, what system of nomenclature is used for naming these inorganic refrigerants. Apart from ammonia, water, carbon dioxide and other inorganic refrigerants are also named in a particular fashion that we will be discussing shortly. Then we know that refrigerants, as of now, they come as a mixtures or blends, either as azeotropes or as zeotropes. And these mixtures or blends, they are more convenient because their properties could be manipulated and we can get all the optimum characteristics. So mixtures, azeotropes and zeotropes, how they are named also is very important. So let us start with the nomenclature of the organic refrigerants. We know that these refrigerants, they are derived from hydrocarbons, and we also have seen that hydrogen atoms are replaced by chlorine and fluorine atoms. So essentially their names should consist of the number of carbon atoms, the number of hydrogen atoms, the number of chlorine atoms and fluorine atoms. So we need to have some naming method, some nomenclature which will give us an idea about number of carbon atoms, number of hydrogen atoms, number of chlorine atoms and number of fluorine atoms. So in order to name it that way, what we do is that we start with the designation as capital R. So in all the types of refrigerants, this is the method that the designation, the nomenclature starts with the capital R alphabet. Then follows the numbers. Now what is the numbers when you name this organic refrigerants? So the first number in the series is about the carbon atoms. So what we do is that while naming these organic refrigerants, we count the number of carbon atoms in that molecule and then subtract 1 from it. So the first number is, as I said, the nomenclature starts with alphabet R, then is the first number. So the first number is 1 less than the number of carbon atoms. The second number is 1 more than the number of hydrogen atoms. This will be more clear as we take 1 or 2 examples of this. Okay. So the first number is 1 less than the number of carbon atoms. The second number is 1 more than the number of hydrogen atoms. And the third is the number of fluorine atoms. The number of chlorine atoms and how they are named, that comes from the balance. Okay, because you know that, for example, if it is a methane derivative, so it would be CH4, and in methane derivatives, suppose one hydrogen is replaced by fluorine, then one hydrogen is replaced by chlorine. The remaining hydrogen atoms, the number of fluorine atoms, they all needs to be represented by a particular number. Okay, so our nomenclature would reflect only the number of fluorine atoms and not the number of chlorine atoms, but number of fluorine atoms can be easily found because you know the total number, that is CH4 means 4 hydrogen. Of this 4 hydrogen, how many of the hydrogen are remaining, how many of the hydrogen are being replaced by fluorine atoms, that would give us indirectly the number of chlorine atoms. Okay, so this way we see that this nomenclature method would account for everything. That is, it would account for the number of carbon atoms, it would account for the number of hydrogen atoms, it would account for the number of fluorine atoms, and indirectly the number of chlorine atoms. So let us simplify this a bit by putting this in the form of some mathematical expression. So I will be putting this as follows. I would call the number of carbon atoms as m. I will call the number of hydrogen atoms as n. I would be calling the number of fluorine atoms as p, and the number of chlorine atoms as q. Now what is done is the balance, which I said is the balance of a particular hydrocarbon, is n plus p plus q is equal to 2m plus 2. Okay, this you all know. In chemistry, we have all studied this. N plus p plus q is equal to 2m plus 2. And then, if that holds good, then the nomenclature method is R. As I said, the first number is 1 less than carbon atoms. Okay, so if the carbon atoms is m, so the nomenclature would be m minus 1. The next number, as I said, is 1 more than the number of hydrogen atoms. So because now we have said that the number of hydrogen atoms is n, so it is n plus 1. And the third number we said is the number of fluorine atoms. Okay, so this way now the nomenclature becomes like this: R m minus 1 n plus 1 p. Okay, let me repeat this: R m minus 1 n plus 1 p, where m is the number of carbon atoms, n is the number of hydrogen atoms, and p is the number of fluorine atoms. And as I said, the number of chlorine atoms is obtained as a balance by this equation: n plus p plus q is equal to 2m plus 2. Okay, so let us take one or two examples so that this becomes more clear to you. Let us take the example of tetrafluoroethane. Okay, so how do we name tetrafluoroethane? One thing is very clear to you, that it is an ethane derivative, right? It is an ethane derivative. Ethane derivative means the number of carbon atoms would be 2. So if the number of carbon atoms is 2, it means that m will be equal to 2. Okay, and we know that the nomenclature starts with the alphabet R. Okay, so the nomenclature starts with R. R is the refrigerant. Nomenclature starts with R. Then, as I said, the first number is 1 less than the number of carbon atoms. So the number of carbon atoms, which is m, is equal to 2, and 1 less than that means 2 minus 1. It means it is 1. Okay, so R2 minus 1, it is 1. So the first number you see in the nomenclature is 1. Why is that 1? Because the number of carbon atoms is 2, and it is m minus 1. Okay, the second number, as I said, is related to the hydrogen atoms. Hydrogen atoms, you know, the formula is CF3CH2F. Okay, so number of hydrogen atoms is 2. And because the number of hydrogen atoms is 2, and our naming method is that we should take 1 more than the number of hydrogen atoms. That is, the number of hydrogen atoms is n, so n plus 1. So n is 2, 2 plus 1 is 3. So there comes the number 3. So 1, 3. Now we have got the first two numbers 13, 1 and 3. The third is about, as I said, number of fluorine atoms. It is tetrafluoro. So it is but obvious that the fluorine atoms number is 4. So this is 4. So your number becomes R134. R134. Now what is this A? A is the way of small a. It is a small alphabet. It is a lowercase letter which is used to specify a isomer. Okay, so we are talking not about the regular tetrafluoroethane. We are talking about a specific tetrafluoroethane isomer which behaves as a refrigerant. Okay, so we are talking about R134A, meaning that there will be two such compounds. One is R134 and other is R134A. It's having the same chemical formula, but the arrangement is different. Okay, so this A, please note, it talks about the isomer. So we are talking about an isomer of tetrafluoroethane, R134A, and just now we have seen that how by knowing the chemical formula or by knowing the name, we can come out with the naming of this as R134A. Similarly, if you are given or if you are asked to find the name of difluoromethane. Okay, so let us start thinking in this same logical way. Obviously your name would start with the alphabet R. The first term has to do with the number of carbon atoms. Now it is methane derivative. So methane, you know that it has a carbon 1. Okay, and it is 1 less than the number of carbon atoms. Your M is 1, so M minus 1 becomes 0. So your first number after the alphabet R is 0. Okay, and it's a practice that we don't mention 0, so we'll just skip that number. Okay, so the first number has to be skipped. So the second number becomes the first number. Okay, so for the time being, let us concentrate and let us say that it is R0. So the first number is now 0. The second number has to do with the number of hydrogen atoms. Now, you know that it is methane and 2 of the hydrogen atoms are substituted by chlorine and 2 of them are substituted by fluorine. So obviously the number of hydrogen atoms now is 0. So the number of hydrogen atom is 0. So your N is 0, but from our nomenclature method, we know that it has to be added with 1. So N plus 1. So 0 plus 1 becomes 1. So it is R0, 1. And the number of fluorine atoms is 2. It is difluoro. So number of fluorine atoms is 2. So it becomes now R012. Instead of saying R012, we simply say it is R12, which is a very famous refrigerant. It was earlier used in household refrigerators. Now it is unfortunately banned. Okay. So now we have seen how to name. Okay, given a chemical formula or given a chemical name, how do we name the refrigerant as R12, R134A like this? That is now very clear to us. Okay, can we do the other way around? It means that suppose you are given the name, can you think about how many carbon atoms are there, how many hydrogen atoms are there, how many fluorine and chlorine atoms are there? So again, this is very simple now. It is just a reverse exercise. So let us take an example of R12. So what is the chemical formula of R12? Suppose you want to find a chemical formula for R12. So R12 means now R012. It means that the number of carbon atoms is 1 more than 0. It is 012. It means the number of carbon atoms is 1 more than 0. So the number of carbon atoms is 1. It means that it is a methane derivative. R12, R11, R13. Okay, all these R22, all these are methane derivatives because you don't have the first number. It is 0. Okay, and it would have carbon 1. So similarly, R12 would have 1 carbon. Okay, what would be the number of hydrogen? Because the number 1 is written over there, it means that the hydrogen atoms would be 1 less than that 1. Okay, number of hydrogen atom would be 1 less than the number which is given, N minus 1. Okay, so it is 1 minus 1, which is 0. Right, so the number of hydrogen atoms now becomes 0. Number of carbon atoms is 1. Number of hydrogen atoms is 0. Okay, It means number of hydrogen atoms is 0 means all the entire molecule is now halogenated. All the hydrogens are being replaced by the halogens, right? Now, of these halogens, how many of them are fluorine? So, because it is straight away given that it is 12, so the last number is 2. The last number indicates the number of fluorine. So, of the 4 hydrogens which are halogenated, 2 of them are fluorine. So obviously the remaining 2 would be chlorine. Okay, so your chemical formula would be CCl2F2. Okay, these chlorine atoms you can also find from this formula. N plus P plus Q is equal to 2M plus 2, where if you substitute the value of P as 2, if you substitute the value of N as the number of hydrogen atoms, if you now substitute the value of M as the number of carbon atoms, then you would get Q as 2. Okay, so now we have also an understanding of how to derive a chemical formula if the nomenclature is given. R12 is now CCl2F2. Okay, let us discuss now the nomenclature of some other refrigerants. Hydrocarbons. Hydrocarbons also use the same method for nomenclature, that is, we start with R. For example, an example of propane is given. You see that the number of carbon atoms is 3, so we need to subtract 1 from that. So 3 minus 1 is 2, so you have R2. The second is number of hydrogen atoms is 8, N plus 1, so the 8 plus 1 is 9, so R29. And because it is purely propane, it is not halogenated, so there is no fluorine, there is no chlorine, so automatically the third number would be 0, so it is R290. Okay, so this is very interesting. This way also you can name methane, ethane, propane, right? It becomes difficult to name butane. If you use this method, you can discover that because butane is a higher configuration, so that hydrogen becomes the hydrogen plus 1 would be 11 or something like that. Okay, so instead of complicating the matters for butane, what it is done is we don't follow the nomenclature for butane as was discussed earlier. Instead of that, arbitrarily, without any reason, we assign the name R600 for butane and R600A to the isomer of butane, which is isobutane. Okay, so R600A is an interesting and very important refrigerant we are seeing, which is an isomer of butane, and its nomenclature is arbitrarily given as R600A. So there is no reason. Okay, we cannot prove that the number comes as R600A by using the terminologies which you are seeing. Okay, so designation for isomer of butane R600A is arbitrary without any reason. Okay. For organic refrigerants, a very simple formula is used. We use the 700 series for organic refrigerants. So what is done is that we simply find out the molecular weight of that organic refrigerant. These are all low molecular weight refrigerants, and add that to the number 700. Okay. For example, ammonia, you know that the molecular weight of ammonia is 17, NH3, 3 plus 14 is 17. So NH3 is R700 plus 17, that is R717. So R717 is the nomenclature of ammonia. Similarly for water, you know, H2O, 16 plus 2 is 18. So R700 plus 18, R718 is the nomenclature for water. Same thing is for carbon dioxide. You know, molecular weight of carbon dioxide is 44. So R744 is the nomenclature of carbon dioxide. Okay, this way you can name the organic refrigerants. This interesting mixtures, as I said, azeotropes, then zeotropes. Azeotropes, as we have discussed, they are the blends. They boil at a constant temperature. Okay, they are a blend, but they behave as a pure substance, and you know that the pure substance they would have at a constant pressure. If you heat that at the boiling point, they would boil at a constant boiling point, and the condensation will also happen at a constant temperature. These are the characteristics of pure substances. Similarly, azeotropes would also behave as a pure substance, that is, it would boil and condense at a constant temperature. Okay, so these azeotropes, they are named again by the series I500. Okay, so I have 500, I502. These are the important azeotropes which are named by this method. Okay, so it starts with 5, and accordingly, depending upon the we cannot, please note that we cannot judge that how much of it. For example, R500 is given, so you cannot say that how much is R12 and how much is R152A. Okay, so for a particular proportion and of R12 and R152A, the name is given as R500. Similarly, for a particular proportion of R22 and R152, you can find out the proportion on your own. We get a very interesting refrigerant which is known as R502. Okay, so just remember that when the nomenclature starts with like this, it is R500, R502, and just note that it is a blend. Okay, and you need to remember what are the constituents of the blend, and you need to also remember what are the percentage of that. Okay, zeotropes. Zeotropes, just as your azeotrope starts with the like alpha number 5, these zeotropes mixtures would start with the number 4. Okay, and zeotropes we have studied that this is also a very interesting mixture. It's an interesting blend, but the blend does not behave as a pure substance. It means that it has a temperature glide. It means that it would have different boiling points, right? So we don't have a common boiling point or a common condensation point. It is a range of boiling points which is known as a temperature glide. So during boiling, during phase change, there would be change in boiling point. During condensation, there would be change in condensation temperature. Okay, R407A, 407B, 407C are the examples. Let me discuss this with the help of a picture. This I have taken an example of R404A. Remember that this A is a capital A and not small a. So capital A denotes that it is a blend. Okay, it is not an isomer. If we had used a small a term which we had done earlier, then that was to show that it is an isomer, not a blend. Okay, so please remember this subtle difference. So R404A means it is starting with 4, so we must know that it is a zeotrope. A is there, so it is a blend, right? And it is a blend of some constituents. Now, for example, what is that constituents? We need to find out. Okay, so as I said that just from the name you don't know, we need to just remember the components. Okay, so R407A, you have constituents like R32, R125, R134A in the proportion of 20:40:40. Similarly, if it is R407B, it is a blend of R32, R125, R134A, but it is in the proportion of 10:70:20. R407C again has the same constituents, but the blend proportion is different. Okay, so you see that this 407, it has got 3 names: 407A, 407B, 407C. It is all capital A, capital B, capital C, depending upon the proportion of the 3 constituents which are fixed. So 407 means automatically the constituents will be R32, R125 and R134A. But the proportions, if they are changed from 20, for example, you change to 10 or 132 proportion, then that becomes B. Okay, if you change that to 23, that becomes C, like this. Okay, so this gives you as an idea about how to read the nomenclature and how to make sense of it. So the outcome of this lecture is that we are now very familiar with the designation of the refrigerants. If you come across different refrigerants, this is not a comprehensive list. If you come across different refrigerants in the market, and if you find such names like R400A, 404, then it would start making sense to you. Okay, we have learned how to name the organic refrigerants, including the chlorofluorocarbons, hydrochlorofluorocarbons, hydrocarbons. Okay, using the expression which I talked about, containing depending upon the number of carbon atoms, number of hydrogen atoms, and number of chlorine and fluorine atoms. Ammonia, water, carbon dioxide, these inorganic refrigerants are named by using the 700 series, and mixtures we have seen that azeotropes 500 series and zeotropes 400 series is used. Okay, this clarifies the nomenclature, and we would be taking such more interesting discussions in the next class. Thank you very much. Bye for now.